Hello and welcome back. I'm sure you're all aware about Stable Diffusion 3 and the controversy surrounding it. As I mentioned before in a community post, even though I was recruited by Stability AI, I wasn't a part of the SD3 fine-tuning team. So I'm going into this just as blind as you all are using the tools available to the public. If you're wondering why I'm not part of the SD3 fine-tuning team, it's most likely because I don't have the credentials or proven track record, or a large social media following as a model creator, or over 100,000 YouTube subscribers, or Twitter followers, or something like that. Nevertheless, that doesn't stop me from exploring SD3 on my own in my free time. You may ask, why even bother working on training this model since there is seemingly no upside? Well, if you've been keeping up with the SD3 news, you may have seen that there's been a community license update regarding all Stability AI models here. There's also a promise to improve the existing SD3 2B medium model. In addition, as of today, Civet AI now allows SD3 2B medium models to be uploaded to their website. Sadly, generation services are not supported. In particular, the Stability AI update stipulates free commercial use if your annual revenue is under $1 million US, which is similar to the revenue share structure of Unreal Engine, a tool that I often use in conjunction with my other art software. It sounds like this was proposed by someone who is simultaneously a creative in the entertainment art industry and also an engineer that works closely with generative AI, but this is just my hazardous guess. Anyway, I'll be going over some tried and true tools such as Kohya's SD scripts in addition to some new ones like SimpleTuner. So this is sort of an update to my SDXL training process and could be useful information even if you aren't going to use SD3 at all. As always, the settings and workflows that I use will be available on my GitHub. At this point, I want to notify you about a few things in advance regarding this video. Firstly, training repositories often change, so it's completely possible that by the time this video comes out, the setup or configuration may look a little bit different. However, the training settings should be processed the same under the hood. Secondly, I was unable to hone in and finalize the best Kohya SD scripts training settings, but it seems like it should be somewhere between 9 times 10 to the negative 5 and 1.5 times 10 to the negative 4. If you aren't a Kohya SD scripts user at all and don't want to learn how to use the SD3 branch, I suggest that you skip most of the first part, but watch the very end of it to see if you like the results there. Then, head straight to the following SimpleTuner part, as I did get decent results with that repository. You can save time this way and see which styles you like the most. Let's get started. The way I approached training SD3 was to first see what tools were available to the public. Stability AI has their own in-house tools to train SD3, and we obviously don't have access to those. A few hours after SD3 2B Medium was released, the very first training repository that was available appeared from Diffusers by Hugging Face. You're free to use this, but I didn't try it that much because I was traveling during that time. According to this article here, and clicking on this link, it supports both full fine-tuning and LoRA training. In the acknowledgements section, for some reason, Hugging Face got Stable Diffusion 3 early access and none of the other well-known training repositories got it, which is kind of weird. But anyway, the second tool that became widely available was SimpleTuner by bgira. If you head over to his repository here, you can see that there is no SD3 branch, which means it has been merged into the main repository, which is great. To see how to do SD3 training, you can go to documentation, and then in here, there should be a quickstart, and then an SD3 markdown file. In here, it'll tell you all that you need to do to get it set up, or you can watch what I do later in the video. It's up to you. SimpleTuner was what I ultimately chose in the end because it gave me the best results. This repository supports both full fine-tuning and LoRA training as evidenced by this SDXL env.sh.example file. Click on it and go over to here. There's export model types, either LoRA or full. So there you go. The third tool that I know of which added support for SD3 fine-tuning was Kohya's SD scripts, a beloved favorite of the community. It does not yet have SD3 merged into the main branch, so to access it, you have to click on that branch. As such, it's still very experimental. I did not get good results using this repository, but I did use it to acquire the ballpark estimate of learning rate with the Prodigy optimizer. The SD3 branch only supports full fine-tuning for now, and even that doesn't seem to actually work. I deduced this by going through the code and also seeing that there's an SD3 underscore train, but there's no SD3 underscore train network, which is usually what you use for LoRA. If you don't believe me, the proof is right here in this train SDXL markdown file. SDXL train network.py is a script for LoRA training for SDXL, and SDXL underscore train with no network is a script for SDXL fine tuning. The final tool that I know of is OneTrainer by NarrowGar, which seems to have an SD3 branch. However, setting up the command line requires you to first get the training script from the graphical interface. In particular, this is a pain point for me since GUIs are just visual interference and open you up for a lot of mistakes. If you go to issues and search for SD3, I assume it's working because there are some people successfully getting errors when training, so feel free to use this if you want. Normally, I would just start plugging in random values for the learning rate to get to a base threshold value as to not explode the gradient. However, since Kohya's SD3 branch supports full fine-tuning and the Prodigy optimizer, I just use that to approximate the learning rate. If you're up to date with Kohya's ST-scripts repository, then you are already aware of it switching to this .toml file format instead of config.json. Before I show you the configuration, let's first set up the environment. On the main page of Kohya's SD scripts, make sure it's on main, go to code, and then copy this HTTPS git URL like that. I'll be using Windows for Subsystem Linux 2 because I want to ensure the closest compatibility. You can try doing this with Windows. Your mileage may vary, it might fail, so I'm just going to keep it easy. And I'm using Ubuntu 20.04. Make sure you've prepared a workspace. I'm just going to use the standard home folder, so tilde, and remember the URL we copied. Go ahead and type in git clone and then paste in that. So it's going to clone it into SD scripts. Should be pretty fast. Now cd SD scripts like that. However, if we do git branch, we're on main and we don't have SD3 branch here. However, we can go ahead and check all the remote branches by typing in git branch and then -a. And the one that we want is origin SD3, so we can just check that out from the remote. Type in git, check out -b, SD3, and then origin SD3. If you're not confident, you can always just copy paste it. So now that you do this, go to git branch, and we're on the SD3 branch already. Do git checkout to go back to main if you want, and yes, pretty easy. Once you're here, I suggest you to set up a virtual environment. What I do is use pyenv to set up the correct version of Python. You can see that I've already set up version 3.10.6. If you're starting fresh, you'll just have system and you'll need to install a correct version of Python with pyenv install followed by the version number. I'm not going to do so because I already have it. However, it's stuck on system, which we don't want. To change the Python version for a specific directory, we can use this command called pyenv local followed by the version number. So like that. And if we run versions again inside this SD scripts, you can see that it's set to 3.10.6 for this directory. You might ask, how do I know that this is the right version of Python that I need? If you go over to the repository and look at the readme file down here, it says required dependencies and Python 3.10.6. Now that we have the correct version of Python, all we have to do is create a virtual environment with this command. I've already done so there's no point in me doing it. Then to activate it, type in source vmv bin activate like that. Now that we have our virtual environment, all we have to do is set up the dependencies. So just follow the instructions on the readme. I'm using CUDA 12. You can tell by NVIDIA SMI right here, and I'm on the 12x version and not 11x. So I'll be using this one. Alright, wait for that to finish. Now that Torch and Torch Vision have been installed, let's go ahead and install the requirements stuff. Put that in and wait again. Lastly, install Xformers. However, we won't be using this, but for peace of mind, go ahead and install this anyway. That's done. No errors. Great. Go ahead and clear for readability and set up accelerate config. So there are directions on how to do this on Koyas, but I'll just show you this machine. No distributed training. No. 3 no's, all, and then FP16. Simple. We should be ready to train now. Let's get into the config file. If you want to use Koya, I suggest following the convention, which means making a workspace. So I'll just call this Koya train, go into it. Remember, this is all outside the SD scripts directory. I'll call this SD3 run 01. And then inside this, I need 3 different folders. So I need a logs, I need a config, and then I also need a model. These 3. Inside the config file will be your toml file. This is the setup that I use. There are a few settings that I've changed, so I'll go through them one by one. Basically, you can consider this section as the spiritual successor update to the SDXL training video. So if you don't care about the latest settings that I'm using for SDXL, skip past the next few minutes until the SD3 specific settings. First, I've changed to SDPA from transformers right here. You'll see why this becomes relevant later, but this was first brought to my attention when Raf in my Discord channel was trying out my previous SDXL fine-tune settings. Apparently, Koya's SD scripts somehow started going out of memory when using the Adam optimizer with Xformers. Here, this person and Koya are having a conversation about it, and Raf found out that using SDPA allows you to barely fit in on a 4090. So it seems like SDPA saved some memory, and I went ahead and tried out SDPA for everything Koya related this time. So I can confirm that SDPA works. For SDXL with these settings, it uses around 47 gigabytes of VRAM on AdamW8Bit fine-tuning. For SD3, it uses around 16 gigabytes of VRAM for AdamW8Bit as well. Just to reiterate, those VRAM consumptions are not for Prodigy optimizer. Second, I was feeling adventurous, so I tried out using multi-resolution noise as opposed to original noise. You can see that setting here, noise offset type, multi-res, and then you can also set some of these settings. I don't know what to use, so I just followed this blog here written by Jonathan Whitaker. The experiments show that you can supposedly increase the dynamic range of the denoise images, meaning that you can get darker darks or brighter highlights in the final model. Here it is. The images on the right feel like they have a HDR feeling. Third is the time step settings. There is a max time step that I decreased down to 950 and a minimum time step that increased to 50. The default values for each of these are 1000 and 0 respectively. Supposedly, this will improve the image-to-image functionality. This will make more sense if we take a look at this nice figure from this blog. In the forward diffusion process, which is going from noise to image, so left to right, at 1000 time steps, you have a completely noisy image, and at 0 time steps you have a pure image. When you set the minimum time step above 0, you start with more of the initial image intact. So you can see at 100 or 200, you have more. And when you set the max time step below 1000, you can control how much of the max noise can be added. So at 1000, it's basically indistinguishable. But if we go to 800, we have more of the image kept. This means that image to image won't go all the way to pure noise in the K-sampler while leaving initial remnants of the original image. I used pretty conservative values, but I guess if you're making a targeted style image-to-image focused model, you can increase the minimum time steps more and decrease the maximum time steps. Just an option to play around with. For me, I did not notice too much of a difference either using this, so maybe it's just placebo. I don't know. There are two more things I want to address here before we head over to the SD3 settings. First, remember to add a prompt text file underneath your model directory if you want to check how your model is doing at a certain interval of steps or epochs. Secondly, if we go back to the toml file, you'll notice that I have in this in.json field a metacap JSON file. This is a JSON file containing metadata of your dataset. You'll have to create this, but I'll show you how. Notice that I've set it here, but I haven't created it because it should be under the configuration directory. I believe the bmulti GUI handles this metacap JSON file creation for you, but since we are going with the CLI approach in SD scripts, let's follow the instructions on the repository. If you maneuver over to this readme document on the SD script docs directory and scroll down or search for it, we have to run this file called merge captions to metadata. You have full path. This is just so you can do it for an absolute path. This command won't run if you run it here because there is no merge captions right here. Do you see the file here? It's not in there. It's actually in this Finetune directory. See? Merge captions to metadata. Now we can run our command. It's doing its thing, and it seems to have finished. Since I used full path, I have my metacap JSON file right here. Go ahead and select it. This is what it looks like. Basically, it specified the path and then the corresponding caption. This just makes it easier for the repository to read in the information, I guess. Who knows? Now let's get into the SD3 settings. Before I start telling you all the differences, I'm going to show you this GitHub issue that bmulti commented on. This is on the kohya SS repository on an issue that someone opened asking, is SD3 training available last week? And 3 days ago, bmulti commented here with a list of the differences between SD3 and SDXL training pipelines. So if you're ever confused on what options are available to you, just consult this list here. I'm sure it will be added to kohya's repository as well. And in his subsequent comment, he elaborates more on the high-level overview and the differences between them. Let's start with the pre-trained model name or path right here. For the time being, you have to use a local model that you've downloaded yourself, otherwise it doesn't work. I tried putting in the Hugging Face repository here, so it was like Stability AI and then SD3 Medium, and it wouldn't work, so I had to point to an actual local copy of the model on my own hardware. To download the model, head over to Hugging Face and then make sure you get permission or get access to the model, go to Files and Versions, and then pick one of these to download. You only need one. I'm actually using this one, T5 floating point 16. However, you can use whatever you want. Next up, let's consult the README from kohya for SD3 training. He has some things that he mentions. You don't have to worry about that too much. However, in particular, he mentions this right here. Text encoder batch size equals 4. It's added experimentally for caching faster. You're free to try it out. I tried it out. And then the other thing that he added was this thing right here. T5XXLD type. He set it to BF16 or float 32. In my first pass, I actually didn't add this and I didn't get an error. However, if we go to this GitHub issue right here, SD3 train loss is not a number, and the comment is telling him or her to change it to BF16. So just go ahead and add it. Also, I want to point out these caching options. If you don't add these 4, your training won't start up. So make sure that is added as well. One last thing before moving on to the final training script is the sample sampler. This is for visualizing how your model behaves at certain intervals during the training, basically generating sample outputs every few steps or every set number of epochs. But nothing was being generated when I did my experiments. Maybe visualizing the results is not supported in the SD3 training branch right now. I don't know. Nevertheless, change the sampler here to use an ordinary differential equation sampler, not a stochastic differential equation sampler. So here I have DPM++, but if you want to be ultra safe, you can just go ahead with Euler. I don't think Euler A will work because that's an ancestral sampler. So yeah, Euler for here. I also want to point out two more things that you may have questions about. First is the learning rate for the text encoder up here. Even though I've set the trained text encoder down here to true and the learning rates to 1, for both of the text encoders, they're actually not being trained. If we head over to the SD3 trained Python file and go to line 225, I believe, the entirety of the trained text encoder and learning rates are all commented out, so nothing will happen. While we're here, I also want to point out something about SDPA. So let's jump there. Here, currently, Xformers is not supported, so use SDPA instead. Thanks, Raf, for exploring that way before anyone else did. My Prodigy settings are more or less the same, but I do want to point out how I got this cyclic learning cycle. If you use whatever is listed here in the toml file without adding in an extra flag, you will get a classic cosine curve that warms up then slowly decays without restarting at all. To get the restarts, you'll have to add 2 arguments to your training script, namely learning rate scheduler type and learning rate scheduler args, with tmax set to an arbitrary number. Mine is set to 600, which is approximately 1.5 epochs for me. Tmax represents the length of a single cycle of the cosine curve, and once it's completed, it'll restart. I set mine to 600 steps mistakenly because I forgot that I added more images to my dataset. What I found is that for Prodigy Optimizer, it feels like 1.5 epochs translated into the amount of steps for Tmax does the best. To get your Tmax size, all you have to do is take the number of images in your dataset, 476 for me, multiply it by the amount of dataset repeats you have up here. I set it to 10, so 4,760, and then with a batch size of 6, you would just divide that figure by 6, and it comes out to be around 794. Since I want 1.5 times of that equals this number. I have my new Tmax value, so I can go ahead and start running this training script. For me, I like to open up a Tmax window, temp, and split it Control B, and then percentage, and move back here. My virtual environment's not enabled, so go ahead and do that. There we go, and then paste in run. We have an error here saying that you need to have sentence piece installed. I guess I'll just install that here, like that. Run my command again. Hopefully it'll go through. Seems good. One thing I want to point out is that I also added in this flag here, which is cache text encoder outputs. When this is activated, I won't be able to shuffle my tokens. So here, shuffle caption is set to false. Now I have another issue, which is weights and biases is not installed. Same thing, clear pip install wandb. Should be pretty quick. And let's go again, 3rd time's the charm. Looking good, looks like it's doing something. Let's go over here to the right pane and check out how much memory I'm using. You can see that I'm on step 1, and this will take an eternity, I believe. I'm barely squeezing everything in, 24.11 out of this much. It's very tight. If you do end up using this Prodigy optimizer, please use a A100 or H100, or else you will not be able to finish this in a reasonable amount of time. Now it's time to check the Prodigy results. The workflow that I'm using is the one provided by Comfy and friends in the SD3 Medium repository. There's a Comfy example workflows right here. Go ahead and use this one, the basic JSON. This is as bare bones as it gets, but we just want to check if our Prodigy full fine-tune is giving us any results that are similar to our dataset. Remember that we trained on 10 repeats with no caption shuffled for 30 epochs, so I should be getting something very similar to my dataset image. These are some images from the dataset, and I'll try to reproduce this image using the corresponding prompt in here. Replace it, I already copied it in advance, and run. It's a very realistic image and basically not stylized at all. We can give it a few more tries. Something kind of stylized, but not really. Another try, and now something completely different. The strange thing is that I'm using the final version of it. If you train for 30 epochs, the last one is named 001, or the final name without any appended numbers or epochs. So 29, and then this is the 30th one. If you don't believe me, we can try the 29th epoch as well to see if we are getting the overfitted result. We're still getting something very realistic, which is very weird. Let's try a different image. Maybe we're just getting unlucky. I'll try this image next. It's by an artist named Kleiner High, I believe. Paste it in, run. And it's still very undertrained. Now we're seeing some proof. The learning rate must not be high enough for Prodigy Optimizer. Let's just do one more example just to confirm our suspicions. And let's get back at it. I wonder what this will give us. It's not even trained in. Not even close. Not even close. Yeah, definitely a far cry away. I can basically conclude that somehow Prodigy training is not working well, or Kohya has some kind of bug in his repository. Just for reference, when I did that Prodigy training run, I believe I was on this commit 381598C. At this particular point in the past, I could conclude one of two things. Either my learning rate is not strong enough, or Kohya's repository is still in the development phase, so it's very experimental and possibly buggy. However, I gleaned quite a bit of information from this figure. When I take a look at it, I see that near the end, I'm going to 6 times 10 to the negative 6 for the learning rate. Remember, this was being very undertrained, even at the end and over the course of 30 epochs. So whatever learning rate I put in next must be higher than this value, assuming that Kohya's repository is working correctly. I rethought my strategy and chose to go with an Adam optimizer next. One thing that I want to point out in hindsight is that if I knew that the Prodigy training wasn't going to work or be very undertrained, I probably should have just used a constant scheduler. If I did use a constant scheduler, I should probably see some kind of fuzzy line bumping up and down, and it would be closer to the supposed learning rate that I should be using. Unfortunately, I did not think of that during this time. My bad. Just for reference, this next round of Adam Optimizer training was conducted using the latest branch, which is this EA181. This is the toml config file that I used for the AdamW8Bit training for SD3 on Kohya. This time I replaced the learning rate with 7.5 times 10 to the negative 6, which is a little bit higher than what Prodigy told me to use at 6 times 10 to the negative 6. The reasoning here is that I'm going to warm up gradually to this higher learning rate, then gracefully decay. Even though I'm using this cosine with restarts for the LR scheduler, I didn't add any arguments, so this will default to a single cycle of cosine. Other than that, everything else is totally the same. This is my fourth run using the Adam optimizer, and it's at that supposed Prodigy learning rate, so not making anything up, this really happened. Here we are back in ComfyUI again to try out our Adam optimizer. So I'll be going with the same example images to see if I am overfitting or not, or if it's severely undertrained. I believe that I should be getting a more stylized, more painterly image. Let's go again. It doesn't seem that it's able to make its mind up. This is closer, but I would still say it's very, very undertrained. I don't know what's happening, but this definitely doesn't feel right. And now I get a realistic image. Let's try out the second prompt again. It's supposed to give me this woman with orange hair outside. Yes, but even though it gives me this is not the style that I trained in. I even have my trigger word front and center, and it's still giving me this thing that basically doesn't have any of the qualities of my dataset. And lastly, my own art piece, Fleet City. It's completely doomed. This is not remotely close to anything in my painting. At this point, I was kind of despairing because, wow, maybe SD3 2B medium really is doomed. Hello, sorry for the sudden interjection, but this is me from the future after I fine-tuned SimpleTuner well to my tastes. I went back and trained Kohya once again with similar settings of cosine with restarts. This means that I manually set the Tmax so that I would get about 5 cycles of restarts, similar to SimpleTuner. Let's go to weights and biases for just one moment. This experiment is Kohya, and this one is the final SimpleTuner training. I'm not making anything up because these charts are both not in in the same format. As I mentioned, this is the restarts. I tried to get 5 restarts, and same with here. So I had to manually calculate the Tmax. See, all that Prodigy training and explanation is kind of paying off now. Nevertheless, to be honest, at this point, I was extremely frustrated, so I took a break and cooled off. In my rage, I started increasing the learning rate because I felt like I was falling into the trap of thinking that SD3 was actually learning the style, when in fact, it was just the prompt adherence being exceptionally good. So you may ask, what is the upper bound of Kohya SD3 learning rate for the settings that I have now? Well, it seems like it could be 1.5 times 10 to the negative 3 as a local maxima. Here is 1.5 times 10 to the negative 3. Go back to ComfyUI and try to run this. This is experiment 7, so it matches up with this one right here. And this is the final epoch because there's no appending number at the end. Let's go ahead and run it. And we get this beautiful image. This is reminiscent of an exploding gradient. At least 1.5 times 10 to the negative 3 could be a local maxima. I don't know exactly where it breaks, but it breaks here. Now let me go ahead and keep it on the same run, but go to the first epoch, run. Will it explode here? And yes, it's already broken on the very first epoch, so I could confirm something was wrong already. 1.5 times 10 to the negative 3 is too much. Why don't we just step down in order of magnitude? 1.5 times 10 to the negative 4. Final epoch, once again, run it. We get something. However, it's overtrained now. That means 1.5 times 10 to the negative 4 is too much. Just to confirm, we can go to the middle epoch, so maybe something 14 or 15. Let's go with the 15th epoch, halfway point of the training. I would say it's still kind of overtrained because we are decomposing into very flat shapes. This doesn't seem right. Now we're here on the 9th run, which is using a learning rate of 6.5 times 10 to the negative 5. A little bit more than where it was undertrained at 1.5 times 10 to the negative 5. Let's see how that does. Final epoch of the 9th run, let's go, and it's undertrained. That means that the ideal learning rate should be somewhere between 6.5 times 10 to the negative 5 and 1 times 10 to the negative 4. What do we do now? This is the final experiment that I did for Kohya, which is experiment 11 at learning rate of 9 times 10 to the negative 5. Let's check this result. It's kind of taking on that painterly texture, but the face is still very realistic. I think we failed on this trial. 9 times 10 to the negative 5 is too weak, but 1.5 times 10 to the negative 4 was too strong. So I am so confused right now. How can the margin be that thin? Let's try some other prompts just for fun. Not quite there yet, but close. If I would go back and redo this, I would just say maybe 0.5 times 10 to the negative 4. Let's do a city this time. Yeah, it looks kind of good, I guess. And then another woman. Yeah, so we're almost there, but not quite. How about this one for fun? Another example, I guess. Yeah, I don't know what's going on with Kohya. I really don't know. After many unsuccessful trials, I abandoned Kohya's experimental SD scripts. It's completely possible that I did something incorrectly with the learning rate or something else, but my subsequent SimpleTuner full fine-tune results say otherwise. So let's go ahead and get that set up. The repository is very well documented, so if you want to start right away, scroll down here, look for this quick start guide in the tutorial settings, click on that, then we want Stable Diffusion 3. There's other options for other models, but it's all pretty similar. Just follow the installation instructions, git clone that. Here we go, just paste that in there, cd into SimpleTuner. Now we have to create our virtual environment. Note that we have dot in front of v&v, so copy that. And if you're following what I've done before with the Pi environment like that, see that this repository is using system right now. We don't want that, we want to set a version for it, so pyenv local 3.1.6. Now we have to activate the environment and also install this stuff here. Back again, just activate this. Remember there's a dot, activate, and then paste in pip install poetry pip and wait for this to finish. Alright, we have poetry installed now, so let's just install all the dependencies with this command. Clear for readability, paste, and let this run. It'll take quite a while, so take a break. The dependencies have finished installing, so let's go on to the next step. The next step is setting up configuration files here. First, it tells us to copy this xdxl env shell file. Before we run that command, just go in here and check that we have that file. It's this one. We're going to make a copy of this file, but just remove the trailing example. Paste in, done, and we should have this new configuration file to manipulate. Before we jump in and start editing this SDXL environment shell file, I want to do one more thing on the command line, which is setting up the weights and biases login. This is optional if you want to check your run, which I highly recommend doing, and also setting up Hugging Face CLI login. If you don't set this up, it won't work because this repository, unlike Kohya's, actually pulls from Hugging Face. Make sure your virtual environment is enabled, pretty important. Just copy the command over, wandb login. It should ask you for your access token. So I'm already logged in, but I'm going to do a force relogin just to show you guys what we need to do. Okay, it's asking for your API key. Once you're in your home page, you can go to the top right, click on your picture, and then go to user settings. Inside here, you can find your API key inside the danger zone. I already have mine, so I'll just paste mine in and enter. It's been added. Great. Let's clear for readability and run the second command, which is Hugging Face. There we go. Now you enter your token. On your home page for Hugging Face, same thing, go to your picture, go to settings, and go to access tokens. And I have mine here already as well. If you already have them created, you can see them by going to manage, invalidate, and refresh. So just do that, and that's mine. Same thing, paste that token, and don't add it as a Git credential if you don't know what you're doing. It has been saved to my cache. Great. Let's get into editing the SD3 configuration file now. At first glance, you might wonder, why are we using this SDXL environment shell file? Shouldn't we have an SD3 file? Great question. For the time being, Bgira has set it up so that this SDXL file also holds the variables for the SD3 training. Here you can see a variable, stable diffusion 3 set to false. First thing that we want to change is make this true. So type that in like that. Make sure it's undercase so it follows the convention set up here. Also, we want to start with the full Finetune instead of a LoRA. So delete this and type in full. The reason being is that the full Finetune gives us a benchmark if trained properly. If we see our LoRA give us images that are pretty similar to the full Finetune, then that LoRA was trained with the correct settings. If we check out what's under this copy command down here, there is something called dataset considerations, and there's all this stuff down here as well. However, what we have to do is create a file called multidatabackend.json in a very specific location, and this is the configuration that Bgira provides if you want to use this pseudo camera 10K as your dataset. However, we are not going to use this. We're going to use our own local dataset. If we go down here to line 66, there's something called the base directory, and then inside this base directory, there will be that multi-data backend JSON file, and then the output directory will be automatically created for you for your models. Simply put, create a directory for your base dir somewhere on your volume, whether that be on your local PC or in the cloud. So same thing in my home directory. You see I have this Kohya train directory. That's where I had my SD3 Kohya trained models. Here I'll make one called SimpleTuner models. Like that. CD into it. Now I want to distinguish between all my runs. So I'll make one called SD3 full 01. Also go into that as well. Remember, we need to have a datasets directory according to the convention. So that's done. And now we're ready. I have my home directory open in VS Code, split the window, and load up SimpleTuner models right here. And we need to copy this multi-backend example JSON into this datasets folder. If you look here, this is what it says to do. So let's go ahead and do that. We'll copy, paste it in here, and let's rename it so we don't have this example in the file name. Now let's make sure to change these path names before we forget. This is not going to be there. We can just go ahead and get this name from in here. So let's open up terminal. We have that file there, print working directory, and copy this over here. So we just want that. Paste it in there. Done. Let's close this down for now and get into modifying this file. file. But there's a lot of stuff here that we don't really need, so go ahead and just delete all of that. Come back to the SD3 markdown file, copy all of that, and paste it in here. Now let's go ahead and change a few things. First of all, I'm going to change the ID so I can have the name of my dataset. This one, Fantasy Art Neo. Done. Type local looks good. Crop, I'm going to change this to false because all of my images are already in the format of 1K, so I don't need to crop these images down. Next, square, center, they all look good. Resolution, I don't know what this does, but I'm just going to put 1.0 because I want them to be the same. Minimum image size, maximum image size, I don't think this will change because we're not doing a crop. All right. Next is cache directory VAE. So make sure the ID matches up here. So this last part should be the same, but I'll just show you what I used for it. I put it inside the training directory here. Here I am inside Ubuntu. Go out of datasets. I should only have datasets. Now I'll make a directory called cache. Inside cache, I'll create 2 folders. I'm not sure if they're created by themselves or not. Make dir VAE and make dir text. So I should have these 2 now, and these are the paths to it. Copy what's here and head over back to VS Code. Here it is. Just delete everything here and paste that in. And remember to have whatever was at the end. So VAE, SD3, and then Fantasy Art Neo, like that. Now we come to instance data directory. This will be the location to where your data set is on your local directory. Go ahead and just reuse what you had for Kohya right here on my E drive. Copy that and paste it in here like that. Great. Disabled, I don't know what that does. Skip file directory, no idea. Caption strategy. This is not going to be file name because in my data set, I have text captions in a text file, as I mentioned before. So what do we change this to? Do we change it to text like that? Well, if you don't know what to change it to, you have to look through the documentation. Let's go ahead and do that. If you're on this SD3 markdown file for the quick start, you can just head over to the data loader markdown file and look for caption strategy, which is what we want. There's 4 options to choose from. The default was file name, I believe, but what we want to change to is called text file. So let's go ahead and just do that. Here we are, delete this and text file. Great, so everything here looks fine. However, you might notice we don't have repeats in. So do we add it in this file or do we add it in the SDXL shell file? Well, if we come back here to the data loader markdown file, it's very interesting to see that there's a repeats. I assume we can set repeats here to our desired number, which for me is 10. Copy this and paste it back in VS Code. Paste like that. There we go. The last thing that we need to do here is just to finish off this cache directory. Remember we created one up here for the VAE. Just copy all of that over and paste it in here like so, and change cache VAE into text, hash text like that. And we're finished. Now let's hop back into the fun stuff, which is the SDXL environment file. The reason why I diverged earlier is because I wanted to set up the multidatabackend.json, making sure that I'm getting my 10 repeats in. Now, I have all the information available to me. Repeats are already set. Now I want to go down here and set my number of batch size just to simulate everything so it's as close to Kohya as possible. So this is 6. I also used a gradient accumulate of 1. Like that. This is just to save VRAM. For now, I'm going to leave it like so and come back here to calculate the amount of checkpointing steps and checkpointing limit. Here, checkpointing steps means every so n number of steps, we will save a checkpoint. And checkpointing limit is how many checkpoints in total we are going to save. So for this one, I changed it to 800. So every 800 steps, I'll save 1. And for checkpointing limit, I put 28. I should have put 30 here because I saved 30 epochs before, right? But I don't know why I forgot to do that here. The reason why it's 800 here is, remember we did the calculation beforehand and I found out that 1 epoch for my data set of 476 images with 10 repeats with a batch size of 6 has around 793 steps per epoch. So I just approximated it to 800. Next up, we have the learning rate. Remember, based on the Prodigy optimizer, I found out that maybe 7.5 times 10 to the negative 6 is the one that's going to work for us. Next is the model name, and you can see that it's currently set to SDXL, which we don't want. If you come back to the quickstart SD3 markdown file and scroll down, you should see that we need to change the model name to Stability AI Stable Diffusion 3 Medium Diffusers. Diffusers, not the safe tensor or checkpoint file, but diffusers. Let's just go ahead and look this up just for fun. This is the diffusers repository on Hugging Face, and this is what we'll be entering in. And paste in that. Looks good. For me, I'm just going to change the name for the tracker project to SD3 training, like so. And then I'll change this to SimpleTuner SD3. Okay, for a max number of steps, if you do the calculation, it should be around 24,000 for me. Please do the calculation on your own. And for number of epochs, I set it to 0. Remember, you can follow this helpful tooltip right here. Max number of steps or epochs can be used, not both. So one has to be set to 0. Okay, and now we're here at the multi-backend.json setup that we all did previously. So that's fine. Go through this. Resolution, good. Pixel, yes. Great. Everything looks good here. Now we're here at the validation stuff. Personally, I was not able to output any validation images on weights and biases, so I'm not sure how helpful this will be for you. However, I'm going to show you what I did to set it up. Validation prompt is just going to be your keyword or your trigger word if you have one, and this is mine. Sure, CFG, rescale 0. Validation steps is how often you want to generate a sample image. For me, I set this to 200, so it's a fourth of an epoch for me. This is the amount of steps you want. Your negative prompt right here, your seed, everything is fine. Now we have our LR scheduler. You can choose from any of these here, or you can consult the documentation to truly see what is there. If you're on the SD3 markdown file, you can go down here outside in the root directory, options, markdown file. So open that one up, look through this, just search for LR schedule or something like that. There we go. Constant with warm up, cosine with restarts, polynomial, all that. I'm going to go with cosine, just add cosine like that. Warm-up steps, I usually do a 10th, and it seems like Gira agrees with me as well. You can either do that or you can manually set it. So for the time being, let's just follow what he did. This looks good to me. For caption dropout, I don't want any, so just change this to 0. I find that it just performs very poorly. VAE batch size, remember that Kohya also recommended to set this. I'll just leave it at whatever default value is here. I had it on 4 for Kohya, I believe that's what he recommended. Min SNR gamma 5 is what I had. This time, it's using Xformers, not SDPA, because Kohya was not able to implement Xformers on his latest version as of this recording. So that looks good. We want gradient checkpointing. The optimizer is set to BF16 to make sure that there aren't any floating point errors. Keep going. Training seed, good. That is fine for me. Now, we can start the training. Contrary to what you may believe, this SDXL environment file is not actually the entry point. It's this one named train_sdxl.sh. So let me go ahead and open it up on the right side. In the first few lines, it is loading the example file and then the custom one that we just edited. So this one, it's kind of confusing. So you can either comment out this third line or just leave it. It's up to you. For me, I can comment it out just for sanity's sake to make sure I'm using the actual settings, but it should make no difference because it is being sourced over on top of whatever's loaded in here. Everything looks to be in order, so let's just go ahead and bash train sdxl.sh, and it's doing its thing, doing a download right now from the diffusers, so that's great. You might notice that we get this issue here, requires max grad norm equals 0.01. Gira has set this to 0.01 for us to help us get better training, I guess. It's doing its thing. The training is running. It's completed, and we can see our metrics from weights and biases, but this isn't super helpful. It's faster if we just test out the models. However, there are some logistical issues that we'll have to solve. Once your training has completed, the output directory will look something like this. Inside datasets, you'll have models, and inside models, you'll have these checkpoint directories. This is kind of an issue because if you have a lot of checkpoints, we're going to have to go in each of these, go to the transformer folder inside of each of them, copy and paste this PyTorch model.savetensors into ComfyUI and do all that stuff. Not to mention, this is a diffusers file, which is different from a standard checkpoint that you're probably used to. Regarding this, I did try to look inside the diffusers repository to find a script that would convert from the diffusers file format into a standard checkpoint, but I only found the one that goes from SD3 checkpoint to diffusers. We want the opposite of this. This isn't going to be too much of a problem because we can load diffusers in ComfyUI. Then the problem just becomes, how do we get our files into ComfyUI without so much manual work? Not to worry, I've created a script here where you can put in your source directory with all your SD3 models from the training repository, and then the target directory will be the models checkpoints folder in ComfyUI. I just want to mention one thing here, which is that I originally had models, then checkpoints. However, since we're using diffusers files, we need to put it in the UNET folder, otherwise it won't be detected. In my script folder, and we want to make this executable, I created them for both the full Finetune and the LoRA. So I'll go ahead and enable both of these. Create symlinks full. Like that. It says that the symlinks have been created, so let's just cd into ComfyUI to see if it's there. ls, and they're showing up in teal, which means yes, we've accomplished what we set out to do. Here we are in ComfyUI, and it's time to load in the SimpleTuner trained models. I'm going to pick the latest one, 24,000, and try to run it. There should be an error happening, but I'll let you see why. Okay, we get this checkpoint loader simple error. As I mentioned before, this is in the diffusers format, so we have to use a special loader called the UNET loader, like that. And then in here, select the model that you want. Same one as well, and hook this into model right here. However, this is still going to error out. What we have to do is just load up the original SD3 model because we still need the VAE. Let's go ahead and pick this one, FP16, and run again. Hopefully this should give us something. Oh wow, I entered this prompt, and what do you know? This seems pretty close to one of the sample images. Maybe it's just placebo. Maybe we're lucky. Let's try another prompt. Okay, this is pretty close to that image that we had before, if you recall, again. So it does seem like it's kind of overfitted, but not really. Let's try again with another prompt. This is the other one, the girl with the orange hair, and we get something like that. So I think this is working. However, let's check if it's overfitting. I'm going to change short orange hair to long blue hair. Let's see if that works. Long blue hair, and it's working. Outdoor icy cold environment. Why don't we change this to inside a desolate factory and remove this stuff about the stalactites. Okay, in a factory working. The style's going off a little bit though. How about a brown tunic, leggings? It's kind of following it, but the style is losing its effectiveness. The style seems to become a lot more harmonious. So an average of all the training data rather than overfitting to a single one. Maybe I should have added caption dropout, but I've never had good results with this. I'm used to having the captions being shuffled, but this option is not enabled in SimpleTuner yet. Let's just try a few more prompts. This one is of a city, I believe. Yep, beautiful. And let's just change some of the stuff. So the background first. I changed it to a tower. Yes, working. Let's change the foreground as well. Change it to a sci-fi village. I don't know what that's going to look like. That doesn't really change too much. What if I change it to sandy beach? Kind of. There's still that city element in the front that's not being changed. And midground. I've tried to remove more of that populated city feel. I'm not sure if that really helped. One thing, I just want to change it from nighttime view to daytime view. Will this change anything? Daytime view. Okay, nice. And then now I'll change blue haze to purple haze. And what about a teal sky? Okay, I'm thinking this is working. It should be overfitting with 10 repeats with no caption dropout or shuffling, but why is it able to change still? I don't know. Something is up here. Let's try another human just for fun. Should be night, great, but this is a waist up view. What if I want a full body view? Full body view. So no, we're not able to get a full body view. What happens if we change the height? Maybe make it 1280. We get to see more, but it's still not giving us a full body. Up until now, you may have noticed that the text prompt has been very long and verbose. What will happen if we use a very short prompt? So just full body view, female adventure, wearing a tunic, simple background. Will this work? Not really. Kind of, I would say. Maybe the proportions are throwing this out of whack. And now the head's cut off, so what's going on here? Oh, now I guess we kind of got something that looks right. Let's keep it in the spirit of short prompts. So what about a male adventure? Wearing a tunic, priest clothing, blonde hair. And instead of simple white background, let's try to put him in in a forest. Okay, so kind of like that, I guess. He looks old. Can we make him younger? Yeah, so it seems like it's taking in the style or one of these styles. Feels like it's a little overfitted, but that can be changed by trying to find the ideal checkpoint. Before doing so, I want to change a few things, such as experimenting with other samplers. With that being said, I'm going to try out this custom node named ComfyUI ODE, which stands for Ordinary Differential Equation and is the type of sampler SD3 uses. If you scroll down here, the authors of the repository have a list of settings they recommend, so I'll try them out. Unfortunately, there isn't any documentation on how to use these, so let me show you how I set it up. This is the default workflow, but with the UNET loader. What we'll need is something called the sampler custom. So type in sampler, and then you should have this one. This is going to replace the K-sampler or run parallel along with it. There are two new things here, or maybe three if you've never seen this denoised output before. But the things that we're concerned with are sampler and sigmas. First, for sampler, all we have to do is type in ODE sampler right here. Hook that in, peach to peach color. Next is sigmas. So I think for this one, we need something called a basic scheduler. Then you have a sigmas output for that. Connect the model up. Remember, the scheduler is SGM uniform, so let's keep it consistent. The steps here doesn't actually mean the maximum of steps. If the ODE sampler exceeds the maximum of steps here, it will just default to whatever here. All we have to do is port over the rest. So model, then the positive prompt, and then the negative prompt from here. Latent image. Okay, looks like everything is good. We can change the CFG as well, 4.5, and then noise seed, let's convert it into an input and hook up the seed from over here. There we go, copy this over and preview image. Let's run it. The prompt is a beautiful female with blonde hair. Let's see if any change will occur. So we have this, and then we have this. So maybe I'll bring out an image compare node and run it again. So we can just do a little comparison. Okay, maybe not because the seed changed. This is without the custom node, and this is with the custom node. With, without, with, without. Maybe in this example it looks better. Let's try a few other ones. How about this one? All right. We have this and then this. Seems pretty close. Maybe it's just placebo. It's up to you. What you think is better. Maybe let's just do another one. So now we have something like this for another prompt. Doesn't seem to have done too much. It seems really cartoonish now, so I don't know why. Might just be how it is. It's up to you which one you prefer. This is more hands-off and this is more hands-on. It's up to you. Now, I'm going to perform a few qualitative experiments. The first one will be the good old-fashioned grids to check which epoch gives me the best style result. For this part, I reverted to the basic workflow provided by ComfyUI. In addition, I've gone back and retrained the model with SimpleTuner so that there was 0.15 for caption dropout. Hopefully, this spreads out more of the painterly style, but who really knows if this is placebo or not. The prompt that I've prepared here is the prompt for the same illustration generation by Kleiner High in the dataset that I've been using so far in this video. This is what it looks like if you generate it, but it's still a bit off from the actual image. To create the grids we know and love, I'll be doing something similar to what I did in the FreeU video, if you remember, which is calling the ComfyUI API with the custom workflow. I'll just refactor this code here to do what I want it to do. It should be a single strip with varying x values and a single y value. Just for reference, this is the modified code that I used. I'm not sure if there are any ComfyUI nodes that support SD3 loaders for checkpoint grids, so I thought it was just faster for me to do it programmatically. This is the first grid result using a learning rate of 8 times 10 to the negative 6 with no caption dropout. We can go ahead and scroll through the grid starting from the left, heading towards the right, but I felt like it was extremely undertrained. This is around the 1/4 point, still has that very 3D CGI render look, and around 12,000, which is the midpoint, it still feels very realistic, and that's not what we want. Let's keep going, but unfortunately, even near the end at 24,000 steps, this is still kind of undertrained in my opinion. What do we do? Let's head back to weights and biases for a short moment. Remember that the SimpleTuner training uses a cosine with restarts type of scheduler, so it seems like we can be more ambitious with our learning rate compared to that of a classic cosine scheduler. For example, this is what we used for the kohya SD scripts repository with a more traditional cosine warm-up and then decay to the end, and we're following the learning rate from what Prodigy gave us. After several subsequent trials, I bumped up the learning rate to around 1.5 times 10 to the negative 5, which is quite a bit more than what I had before at 8 times 10 to the negative 6. In this particular trial, I also added in 0.25 for caption dropout, so about 1/4 of the captions from each text file were removed during the training. The results of that training and grid are here. So we're starting off very realistic still. Quarter way through, we're still realistic, which is disappointing. But around step 9,600, we're getting more of that look, but then we quickly return to that realistic style. Keep going. This is around the halfway point, and it's still disappointingly realistic. Now we're bumping back into more stylized world, and it stays consistent and starts developing this style, which is pretty good news to us. If we keep going, you could choose any number of checkpoints from the end at 24,000 to maybe around even 19,200. So the later 6 of the runs look pretty good to me. So why don't we go ahead and try these out? The second test that I want to perform now is a pseudo-ablation study for the prompts. In machine learning terms, an ablation study means that you remove certain layers and calculate new metrics to see the influence of removed layers. For me, I'll do it with this caption dropout trained model with the epoch that has the best style adherence in my opinion. It just turned out to be this run at the checkpoint 20,800 steps. I'll slowly remove prompts from the original prompt to see if the style stays consistent while keeping a fixed seed. The reason why I'm doing this is because I feel suspicious about SD3 training so far. I feel like it overfits more on prompts than actual visual information. So let's see if that holds true. First one, they should be about the same because I didn't change the prompts. And if we go over to the image comparer node I set up, it should be the same. Good. Now we'll slowly remove prompts from the second one over here. Going to take out the background stuff like that and see what happens. Well, if I take that out, it becomes more realistic. That is very concerning to me. And you can see the full image here. Let's go ahead and take out even more of it. Now there's no background information. And it comes back to being stylized, sort of, but not this painterly style. This whole composition changed. Feels a lot more digital painting as opposed to brushwork. Okay, let's take out even more. So now we don't need this. This time we have this close up. It's feeling a little bit more semi-realistic. and more of that digital painting has crept back in. So it's a far cry from this. The prompt adherence is very good because the pauldrons are kept. I'll take that out as well now. So it'll just be short orange hair with open golden eyes, like that. Once I do that, now we have this portrait shot, and the painterliness has come back, in my opinion. I do think that this image right here is very overfit to the prompt, and this, with less prompt information, it defaults to the natural style of the trained model. So this image here would be more representative of the style of all the average visual noise, in my opinion. I'm not sure if this is true or not. Now let's go ahead and change a few more things. So no longer is it a true ablation study. We'll take out the orange hair and change it to a different color. So black. Will this change the style? The style stays pretty consistent, I would say. Now let's try with a piece by Entei Ryu. She's probably one of the best artists alive, in my opinion, in addition to Klein, who painted this. This is the image generated from Stable Diffusion 3. Let's go ahead and take out some of the prompts here. Start slow, take out the halo and the abstract background. Once you do that, some of the style has been removed, but it actually doesn't seem like too much is being taken out. Composition remains the same. Seems promising so far, but remember, we still have a lot of tokens here. Now let's just take out these purple rags. It may be less chaotic now, I don't know. It's finished. We have less of that noise, and we've lost graininess. This graininess is no longer present, and instead we have this more semi-realistic painting, I would say. So it seems like my hypothesis is being proved. SD3 overfits more on prompts than visual information, but we can't be sure. I'll take off the white wisps and also run it again. We're losing even more of the style, but as I mentioned before, we're probably regressing back to the average visual noise now. This is more of a specialized case, and this is not. Very general. I don't know what else to remove here. Let's just maybe open her eyes. Wearing oriental white dress. And instead of head tilted upwards, I'll say downwards. And instead of red hair, let's give her blue hair. I often find that the prompt adherence is really good. And after making the changes, we have something like this. So the style has more or less stayed consistent, at least with the average visual information. I didn't specify a kimono, but it defaulted to that. Lastly, let's do one more example on my own work. This prompt will actually give us a realistic sculpture, or it should, because the base image in the training set is a render. This is what it looks like, which is kind of realistic. Not really. Definitely looks different from what I had before. Let's start taking out bunches of stuff. Okay, I am a little shocked because I told it to remove the green branches, and it did. That is terrifying. It's still keeping its look, and it's not defaulting into the painterly style, which it should. Cut out more. This will be a really good test to see if it overfits. And yeah, it seems like when I remove more prompts, it regresses to an average visual noise. And in this case, it's the average visual style of all the images in the dataset. The less tokens you have, the less it will overfit. I guess that's what I'm learning here. I don't know how to prove this, but this does seem to be the heuristic here. Now, it's time for LoRA training with SimpleTuner. In my opinion, SD3 full fine-tuning seemed to work pretty well, albeit with some interesting caveats. As a result, we should use what we've learned from there in the following trials. Before I get to the LoRA grids, I want to briefly go over the environment setup, which is pretty similar. Make sure you have a folder for LoRA training ready in this format. This is my SD3 full fine-tune, and this is my LoRA. It's the same. So you have your cache as a separate folder, and text and VAE should be created automatically. And then you have datasets with a models folder and a multidatabackend.json in the root of that datasets folder. I just changed it to target the SD3 LoRA folder that I'm in right now. In addition, I created a duplicate of this stxlenv shell file and named it stxlenv_LoRA. If we bring that one back here, there's a few key differences. The first one is on the right, the full fine tuning has the model type set to full, and for LoRA, it's set to obviously LoRA. And then if we scroll down, there are extra settings here called LoRA rank and LoRA alpha. These should be pretty familiar to you if you've done any LoRA training in the past on the past models of SDXL and SD1.5. If you're not sure where I got this argument from, let me go back and show you the options markdown file. Once again, we're back here on the SimpleTuner repository, and in the root of this repository, you can head over to options markdown file, type in LoRA. It brings us to all these things right here. If we want to use it, we can either use the train Python file, which is not what I'm doing. And if you're not using these flags, then you just use this variable to declare it, LoRA rank and LoRA alpha. And you can see that I was trying out some wild ranks here, 384. As a retrospective / cautionary tale, I want to point out here that even though I manually set the LoRA rank and LoRA alpha, it still gets overwritten by 16 for the rank and the alpha. So what's going on here? With that being said, I highly recommend you to make a duplicate of this train SDXL shell file. Copy, paste, and then rename this to have LoRA in it. The reason why is twofold. You don't always want to be switching these out, so you can just duplicate this and then change this to whatever your LoRA environment file is. So mine is just _LoRA and _LoRA, like that. This way I can just run bash train _SDXL LoRA, and it will run my LoRA version instead of going into my train SDXL vanilla and changing it every time I want to run it. So this just keeps your workspace cleaner for you. If we head over to our train SDXL LoRA script and scroll to the bottom, there's this accelerate launch command with all these environment variables being set to these flags. If we go back and search vanilla LoRA with everything under case like so, it will find a few hits, but the first two are not what we want. These are just the shell environment files. And then there's one occurrence of LoRA here, which is choosing either LoRA or DORA. However, if we keep searching, there is nothing regarding the LoRA rank or the LoRA alpha. This is quite concerning. Once again, we come back to our good old friend, the options markdown file in the documentation. And if we search in here for LoRA, in the usage, there are flags we can set. So lowercase LoRA rank is set to uppercase LoRA rank, and same with LoRA alpha. Now that we know what these flags are, we'll just set them accordingly in our shell file. Back at the train SDXL LoRA shell file, good idea to make a copy of this, so select that, YY, you're using Vim, go to the end, paste. Now we have to add in our arguments. If your VS Code is not word wrapping, just go Alt-Z, that's the shortcut for that. And now just type in \, follow the convention, that to go to the next line, -- LoRA rank. This is not new, I'm not making anything up. This is just what's from the documentation. $, LoRA rank, like that. And then you also want one for LoRA alpha, like so. That should be good to go. Here, I want to show you a comparison between different runs. Remember, originally we had LoRA rank 16 and LoRA alpha 16. And on my subsequent runs where I discovered this issue and fixed them, LoRA alpha and LoRA rank are both at 256, which means that my adjustment to the accelerate command was crucial. And the results will prove this as well. That being said, I have quite a few grids to display, and they are mostly failed experiments because I didn't catch that LoRA mishap until I was about 70% through my trials. Let's take a look at the ones that didn't work first. To be honest, these failed cases alerted me to my mistake. First up are the rank 16 LoRAs. I'll start with the most insane one, which is 1.5 times 10 to the -3. This is an absurdly high learning rate, especially for a LoRA. Start here at the very beginning, and it still has that very 3D-ish render look. And what we're looking for is something more painterly and simple, but this is not it. It's way too simplified. And we can keep going. At this point, it becomes very saturated. Again, another saturated image, and then then lastly, at the end, it starts becoming a cartoon, sort of. More on this later. However, when you do see a LoRA start to saturate heavily, it means that training has usually failed at this point. The reason why the LoRA doesn't take on a painterly texture like the dataset is because a lower rank lacks the capacity to store more information. I don't know why I didn't see this earlier. What happens if we lower the learning rate to 4 times 10 to the negative 4, which is an order of magnitude less than 1.5 times 10 to the negative 3? Let's take a look. At the very beginning, it's still 3D-ish, semi-realistic, starting to become cartoonish here, sort of, but not resembling the final image. And at this point, it's still a disaster. Halfway point to keep going. You would say this is about 3/4 of the way. It's still resembling the base SD3 model this much. Very poor, very poor. And even at the end, it's definitely undertrained. Maybe it's just the prompt. However, when I try it on a different prompt, I get very cartoonish results. This is not expected behavior if you want a properly trained LoRA, and even at the end, it doesn't lose this cartoonish look. Then what if we increase the learning rate? This is 9 times 10 to the negative 4, still not resembling what we want. In fact, this seems pretty bad even though the learning rate is so high. It's not able to get rid of that 3D look. Around the last 20%, it starts to do so, but then again, we probably get this kind of broken gradient at the end here. At this point, I was kind of despairing, but then I found my mistake. Now we can see what it actually should look like. This is learning rate 1.5 times 10 to the negative 3, so the absurdly high learning rate, but this time I increased the rank to 256 and the alpha to the same amount as well. In the very first epoch, we get this really messed up image of noise, then it just becomes black. So I can say for certain that 1.5 times 10 to the negative 3 for these LoRA ranks at 256 is definitely the upper bound of what's not going to work. After that, I dropped down to 4 times 10 to the negative 4 for LoRA rank of 256 as well. It started off pretty poorly, still not good. In fact, it seems very bad, and I was about to lose hope. However, if we just keep going and be patient, we encounter this saturation, and then it somehow starts to rubber band back. At this point, I was thinking, oh, it's picking up the painterly texture now. And lastly, at 24,000 steps, this does seem pretty reasonable to me now. At this point, I wanted to confirm with another prompt. This time it's the man again, same learning rate, same rank. We still have that cartoonish look going, and once again I was beginning to despair. However, the results may surprise you. Around 20,000 steps, we start to pick up some of the painterly detail, then it hammers it out until here. And lastly, checkpoint 24,000. How did this happen? How? Please explain this. It barely got it at the end. What happens if I increase the learning rate a little bit more? Same prompt, same seed, same everything, just that the learning rate has been bumped up from 4 times 10 to the negative 4 to 6.5 times 10 to the negative 4. And you would think that we would achieve the painterly quality or texture earlier. We kind of do, and then it becomes poor, and this is really not good. We never really approached that fidelity once again. I guess 6.5 times 10 to the negative 4 is too much of an increase. Back in ComfyUI, and the purpose is to do a comparison between full Finetune and LoRA. I'll also do the ablation study here for LoRA. It's done running, so let's go ahead and compare. This is full Finetune and this is LoRA. Not as good, I would say, but kind of similar. If I tried different learning rates near 4 times 10 to the negative 4, we might get a better result. Now let's try with less. So take out this and run it again. Full Finetune, LoRA. So LoRA is failing pretty hard. Take out more. Full Finetune, LoRA. So I don't know, your mileage may vary, depends what you want. And we'll just take out even more here. full fine-tune LoRA. So just not as good, but I guess comparable. It's up to you. I personally would not use the LoRA if I could use the full fine-tune. Next up, let's try the male test we did before. Full fine-tune LoRA. In this case, I guess, depending on what you like, the LoRA is not trained as hard because it's still just 256 for the rank in alpha. Of course, there will be remaining 3D, CG, or realistic elements in it. So up to you. Start removing stuff for the ablation study. Full fine-tune holds down pretty well. LoRA starts to go off. Take out even more. Full fine-tune LoRA. So I would say that full fine-tune is winning pretty hard so far. Now let's do the other test, which is The Woman by Entei Ryu. Is a sculpture paint over, if you remember. So this one, full fine-tune LoRA. Yeah, LoRA looks kind of too much, too saturated. Maybe that will change if we take out some stuff. Full fine-tune LoRA. I think you get the idea. LoRA is just not quite there yet. Lastly, I just want to show off some environmental shots. So this one is full fine-tune. This is LoRA. LoRA is a bit fuzzy. This one is a bit more fleshed out, I would say. This is also a piece by Kleiner High. Let's see another environment-focused piece once again. Here we go. Full fine-tune LoRA. Just not enough information in LoRA, I would say. You could probably make the rank even higher, possible, but it's just, I don't know. Other people can try this out. There you have it. This was my foray into SD3 2B medium training using community tools, and I definitely felt very humbled by the new architecture and resulting training ordeal / nightmare. As always, all the training settings will be on my GitHub if you want to follow along or use as reference. You might wonder why I didn't go back and refine Kohya more, or why I didn't incorporate the extra settings such as timesteps and noise and whatnot into the SimpleTuner trainings. Personally, I reached a point where my physical well-being started to be negatively impacted, so I just wanted to be done with the training and editing of the video as soon as possible. A secondary reason is that I felt that I was reaching the point of diminishing returns and further improvements wouldn't have yielded that much. Plus, there is a promised 3.1 update to Stable Diffusion 3. One last thing that I want to point out is the incredibly good adherence to the dataset images. It could end up being a double-edged sword as generations may not be transformative enough, thus violating copyright. That's all for today. Thanks for watching and see you all next time. Bye.